We're recording. Who's here?
Eric, your backpack's
My backpack is chill.
And last friend. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangelo, defende nos in prego. Contra nequitiam et insidias diaboli, est operisti, impere illi Deus, simplices deprecamur. Tuque, princeps malitiae celestis, Satana, aliosque spiritus malignis, quia perditionem animarum pervegantur in mundo, divina virtute in infernum deturum. Amen. In nomine Patris et Filii et Spiritus Sancti. Please have out your in class 65. That is for today. We're going to check in just a moment. Let me see what we have. Yeah, I need to. Yeah. Okay.
I didn't do mine because I left mine here.
Tomorrow. Don't forget, otherwise, because the computer thinks it's a zero in the meantime.
Don't put it on the ground, that's littering.
Oh. Okay.
Eric got it right. He probably didn't read his own.
Did you get a number? What? 4 turns?
Yeah, I mean, you have like 2 seconds to quickly read it.
I got primes.
Mary, are you okay? I just didn't do it.
I had a feeling that it was not primed, but I didn't know how to do it, so I don't.
Eric. Mary. Nothing, I forgot. No, yes I did. What? Yes I was. How did you know that? What? Next time I'll have something to say. Mary. Eric told me to say hi. So hi.
Just as a note, on this and also on the test, there are going to be problems that factor more than once.
You did it right, Mary? Yes, your credit.
So here.
I didn't do the horn because I left my folder here. Yes, I did it. It was someone put in lost and found. That's what I kept finding when I came back. Because I grabbed it and Joseph left his bag here, so I looked at the last round too. And it was. Maybe we need a clock jar. We're eating really bad.
All right. Have a red writing utensil at the ready. Hold myself
You know what?
into view. What's that? Oh. Beg your pardon? Oh. Take out your red writing utensil. Let's see what the answers are. In class number 65. Grab my copy. Number 1. The only thing that can come out of number 1 is a GCF. It's 11xy. Then inside, it's a little complicated. 11xy on the outside, then parentheses, 2x squared y to the 4th, plus negative 3x to the 6th y, plus 11. Do we need to repeat it? Number 1. Okay. Number 2. It unfoils x plus 8, x minus 9. Couple of things with that. Number 3. Factors twice. Pull out a GCF of 8. It should be 8 parentheses x squared minus 4, but then that factors by difference of 2 squares. So final answer should be an 8 in front, followed by x plus 2, then x minus 2. Make sense? So if it doesn't match yours, write in the answer, please. Number 4 actually does factor. It's a binomial squared. It's 4xy plus 3z parentheses squared. Number 5 factors by grouping. It's 2x plus 3, followed by x squared plus 3. Yeah. 4, yeah. It's 4xy plus 3z parentheses squared. Yeah. 5, yeah. 2x plus 3, and then x squared plus 3. Any of the repeats of number 5? Number 6, factors twice. Pull out a GCF of 3, so you should have 3 parentheses x squared plus 4x plus 3, but that unfoils. So you should have a 3 in front, followed by x plus 1, x plus 3, or x plus 3 plus 1, that's fine. Number 7 is prime. Number 8, factors twice. Pull out a GCF of x squared. That should leave x squared parentheses x squared plus 8x plus 16. But that factors by unfoil or binomial squared, either one. Final answer should be x squared, x plus 4, x plus 4. Or if you want, x squared and then x plus 4 parentheses squared. Either one of those.
Wait, can you repeat that?
Yeah. X squared in front, x plus 4 parentheses squared behind. Yeah. 2 was x plus 8, x minus 9. Any others? First page. Yeah.
5.
Number 5 was 2x plus 3 and x squared plus 3. Next page. Number 9. Well, that's a pass about 4 pages to get there. Number 9. These are the magic pair ones. Number 9 does factor. It's 3x plus 2 and x minus 7. Plus negative 7. Number 10 factors. 2x plus 1, x plus negative 5. Number 11 factors. 3x plus 1, 2x plus negative 3. Number 12 is prime. 13, that unfoils actually a difference to squares. It did say, did anybody do the magic pair one? The instructions did say to do it, but you didn't actually have to if you have an easier way. Okay. If you did the magic pair, you should still get the same answer. X plus 3, x minus 3. That was kind of to prove that magic pair is like super duper tough. It'll factor everything that all the other methods will factor. It just takes longer. Number 14, 5x plus negative 3, 2x plus 5. And it repeats up to number 14. Yeah. Number 9 was 3x plus 2, x plus negative 7. Yeah. Number 10, you said? 2x plus 1 and x plus negative 5. Any others? That bitch. All right, from 15 on out, it's nothing but factor however you can and factor as many times as you can. Number 15, factors twice. Pull out a GCF of 3x and then the other part unfoils. Final answer is 3x, followed by x plus 2, followed by x plus 1. Or x plus 1 and x plus 2 could be swapped. Everybody catch that? Okay. Number 16, factors twice. Pull out a GC. Did anybody do 3x plus 12, 3x minus 12? Yeah, that still has GCFs in it. You have to pull out a 3 from the first parentheses and a 3 from the second parentheses, making a 9 in front. So if you did that, you'd get half points on the test, but you wouldn't get full points. Pull out a GCF of 9 right away, and it makes it a lot easier. So it should be 9 parentheses x, where's number 16? 9 parentheses x plus 4 parentheses x minus 4. Number 17, factors by magic pair. 3x plus negative 1, 2x plus 3. I think we did that on the board too. That's in the notes. Number 18, oops, that's pencil. 18 is x plus 5, x squared plus 7. That was factored by a grouping. Number 19 is prime. Number 20, factors by GCF of x plus 5. And then the other part on foils. So your final answer for number 20 is x plus 5, x plus 5, x plus 3. If you want to be sneaky, you could do x plus 5 parentheses squared times x plus 3. 21 factors by magic pair. 7x plus 4, x plus negative 1. And number 22, factors twice. Pull out a GCF of x squared. If you factor by grouping right away, you'll still have a GCF trap in there. Yeah, question. 20 is it? 3 parentheses. X plus 5, x plus 5, x plus 3. Okay. Back to number 22. I'll get just a second. In front should be x squared. Then factor by grouping is x plus 2, x squared plus 5. X squared, x plus 2, x squared plus 5.
Well, I was gonna ask you, like, if we did make, 22.
Oh, 20, we did not, yeah. Trust.
Could we do 16?
16, yeah, 3 parts. 9 in front, then x plus 4, then x minus 4. Any other repeats up to number 22? All right, about to sneeze. Oh, I hate that. Okay, I'm stuck with a sneeze. Whatever. If I sneeze in the middle of this, I apologize. Number 23, pull out a GCF of 23. Then you can factor by difference to squares. So it should be 23, then x plus 2, then x minus 2. Number 24, it unfoils to x minus 3, x plus negative 3, x plus negative 9. Number 25 is prime. 26 has you factor by grouping, and then the remaining stuff factors by difference to squares. So you have 3 parentheses in number 26. 3x plus 5, x plus 2, x minus 2. 24 unfoils to x plus negative 3, x plus negative 9. Did I just say that? Yeah, whoops, I didn't backtrack, sorry. 27, my fault. That's a binomial squared. That is x plus 3y, parentheses, squared. 28 is prime. 29, the only thing you can do is a GCF of negative 4. So it'd be negative 4, parentheses, 2x squared plus 3x plus negative 1. Now again, the thing in the parentheses, I would have tried to magic pair that. It fails, but it's not your fault. It's just a dud. So do not write prime if the magic pair fails. If anything factors, even teeny GCF, it's no longer prime. So the negative 4 in front means it's not prime. So negative 4, parentheses, 2x squared plus 3x plus negative 1. Okay. Number 30, there's a GCF of 3x to the 8th. Then inside will unfoil with, will factor by difference of 2 squares. Your final answer should be 3 parts. 3x to the 8th, followed by x plus 5, followed by x minus 5. And it repeats up to number 30. Yeah, trust me. 26. Three parentheses. 3x plus 5, x plus 2, x minus 2. Okay.
30.
30. 3 parts. 3x to the 8th, then x plus 5, then x minus 5. Any of the repeats except for number 30. Extra credit should have 4 parentheses. X plus 2, x minus 2, x plus 3, x minus 3. That, I'll show you a trick to do that today. But any last repeats? All that's out of the way. Questions? Grab a marker. Any of those you want to see dissected? Basically, if you don't think you can do them easily and comfortably on the test, ask a question. Go. 6, step on. Get rid of this stuff. 6 looks like, yeah, 3x squared plus 12x plus 9. Very first factor, start. Very first factoring method we always check, Mia Jackery, is what? Say again? What's the first type of factoring we always look for? Always. The first on the left. GCF, correct. Is there one on this one? Sorry, there's a tower going. 3, very good. So I'm going to pull out the 3. What's left behind when you do that? Good. Plus 3. Excellent. Now that's good. Does it factor again? Right.
Yeah.
How? What method? Okay, but what would you do?
Would you do the x plus?
Okay.
Yeah.
The 2 parentheses? By the way, keep the 3 in front, don't lose it, but, and then x plus, and then what 2 numbers are you looking for? How do you find it? Isabel, how do you find these 2 numbers? What are they looking for?
It's something between the 4x plus 3.
True. There's something about the 4 and something about the 3. Does that help? Good. I'll catch you on the next one. Go. Mary. 2 numbers that add up to 4 and multiply to be 3. Brennan, are there any like that?
Yeah.
Like what? 3 and 1. X plus 3, x plus 1. And that's called unfoil, by the way. 3, 2, 1. 3 terms, degree of 2, 1 in Brent. And it worked. And we're done. Does that make sense? Next. Any of the ones that you don't feel at all comfortable, even if you're slightly uncomfortable, ask. And I'll see if that answers. Yeah.
Can you do 27?
27. Yeah. X squared plus 6xy plus 9y squared. Now the xy probably threw a bunch of people. What's in the name? I'll tell you. What's the extra letter doing in there? That means that a lot of the factoring methods are going to crash and burn. This is not a normal polynomial for one thing. Bases are supposed to all be the same, they're not. But is there a GCF, Jack Gilbert? Is there anything all 3 of these terms have in common? A 1, and that's pretty much it. So, and we normally don't pull a 1 out unless we have to. They don't have an x in common because this doesn't have any. They don't have a y in common because this one doesn't have any. And they don't have numbers in common because this just has a 1. So no GCF. Can't unfoil. Well, 3, you could try. 3, 2, 1, but the XY, it's like, what the heck? So I'd say skip on FOIL, because this is an alien beast that just came into the world with a problem. Binomial squared. What's the 3-step pattern for binomial squared? Rosie?
Square the first, double the product, square
Square the first, double the product, square the
the last.
last. Does it look like they might have done that? If so, tell me where it came from. Where did this come from?
X.
X. Where did this come from?
3y.
Theoretically, you're done. How do you check your answer? You did the square the first, you did the square the last. What's still remaining? Yeah, that should be the what? What's the step that covers that?
Double the product.
Double the product. Let's see if it actually works. What's x times 3y?
3xy.
3xy. Double it.
6xy.
Okay. This must be right. Does that make sense? If it had come up with like 8xy, I'd have to throw this away because it wouldn't work. All 3 terms have to work. The first term and the last term are easy to calculate, but you have to use the middle term to check to see if your answer's right. Because sometimes it just, like 20% of the time it fails. Questions? Next. Any others? Yeah.
Can you put 26?
26, yeah. Got it. 26 looks like this. 3x cubed plus 5x squared minus 12x minus 20. Again, I would add the opposite almost immediately. The only time I don't is when you have difference two squares. Because difference means subtraction, so I really don't have much choice. Recommendations? Actually, Maria, help me out here. How many terms does this have? What does that kind of remind you of? Factor by grouping. Let's try it. If it doesn't work, it doesn't work. Is there a GCF? I should have asked. No, good. Always check for GCF first, like I almost did there. And then, try the first pair form. Yeah, quick.
Why don't you just do 3x in 12x, or 3x cubed in 12x, and then 5x squared in 20?
And 20?
Yeah.
The question is, in other words, could we switch these two around?
Yeah.
It says yes, you could. As long as it's a plus sign, and then you don't leave it subtract, commutative property saves you on that point, so yes, you could. And if it looks better, great. You will get the same answer either way. You will get an identical answer either way. Give me the first pair. What's the GCF here? And they actually have how many in common? Yeah, they have an x squared in common. They both have 2 x's they can spare. What's left over if you do that?
3x.
Good. And Catherine, take over. What mini GCF would you use here? I'm sorry. 2 is good. There's actually something a little bigger. 2 definitely works. Not much bigger. What goes into 12 and 20? What's that? 4, correct. And there's one little catch. Let me see it. Go. Has to be negative. If the first term is negative, pull out the negative. So negative 4. Let me see. Rob, what's left over if you pull out a negative 4?
3x and 5.
Plus 5. Is that good news or bad news for this?
Good.
Good. What happens now?
You pull the 3x out in front.
Right. Pull the 3x plus 5 out of front. I do.
And then,
And then what's the leftovers?
x squared and negative 4.
Right.
Plus negative 4.
Plus negative 4. Does anybody see one more thing that factors? Yeah.
X squared minus 4.
That's x squared minus 4. What does that split into?
X plus 4, plus 2.
X plus 2? X minus 2. What technique is that?
Something of 2 squares.
Difference of 2 squares, yeah. Difference means subtraction. Difference of 2 squares gives you 3 parentheses. Does that make sense? Next. Any others you want to see? Now's a good time to ask. Don't let this go by if there are any of these that are stressing you out at all. Now's a good time to ask. don't care how basic it is. There's no stupid problem on this question. That didn't make sense.
No.
There's no stupid question on this worksheet. I don't put stupid questions in my worksheets unless the typos, in which case I just do. And the other ones? Yeah, go. 30. Yeah. Three x to the 10th minus 75 x to the 8th. The GCF is a little hard to see the number wise. But let me see something they have in common. Go. 3. 3 goes into 75, and also
3x
to the 8th. They both have 8 x's that they could give up, and 3 goes into both of them. What's left over after you do that? Go ahead. What's left out of this?
X squared minus 25.
Nice. Think of quarters. 75 cents divided by 3 is 25 cents. Does anything factor in? Jack over. What's that? I'm looking over here. Looks like a square minus a square. What's that called? Difference of 2 squares. What does it split into? What does x squared split into? X and x. And then 25? 5. And then how do you make it a difference of 2 squares down here? What do you put here and here? Andy? 1 plus, 1 minus. And then the 3x to the 8 should stay in the front. And that's it. Questions? Get a little better on this? So hopefully at this point, you should be comfortable with GCF. You're reasonably comfortable with unfoil, binomial squared, difference 2 squares, grouping, and now, I don't know if you said comfortable, you don't have to fall in love with it, but magic pair. So multiply the first and last terms, list all the factor pairs, find the magic pair that adds up to the middle term, substitute it in, factor by grouping. Alrighty. Put that away, please. Take out your notes. This is the last factoring method I'm going to cover. There's one more worksheet after this, which tells us, like, after you get done factoring, what do you do with these problems? That's coming out. But for this one, I will warn you, this is the weirdest. Yeah. Absolutely. Yes. This is the weirdest looking factoring method of all. And it is also optional. I mean, not for this worksheet, I want you to know how to do it. But on the test, you will never have to use it. It's designed to make an existing problem easier. It's not designed to be mandatory. It's called substitution. It is also known as pseudo-square. Does anybody happen to know what pseudo means? It's a Greek prefix. If you've had, I don't know if, let me see. You're probably going to have biology next year. If you had life science, you might have studied these things. Has anybody ever heard of a creature? It's a microscopic organism called an amoeba. A-M-O-E-B-A. It's like a blob that sort of oozes its way across. It's very interesting. It's like a one-celled organism that just sort of oozes itself from place to place. The reason I bring that up, like here's, it might look like this, under, there'd be a nucleus, and then there's a bunch of like stuff, cytoplasm in here.
Wait, where do they live?
They live in water. They live in like certain rivers and things like that. They're not the healthiest thing to drink. Like if you get it into you, there's certain types of amoebas that can actually make you very sick. It's called amoebic dysentery. But in other words, don't go out of your way to go drinking them. They usually are not found in places where we find normal drinking water. But if you're out in the middle of a swamp or something, don't go drinking the swamp water. And they'll give you alerts. But the way these things move is that they start as just this sort of, it looks like a fried egg-ish. Then they start stretching their body in, like they stretch out this sort of part of themselves. They look like this. It starts oozing this way, and then the whole thing would eventually it sort of flows the entire thing into that extension. It sort of kind of stretches this sort of foot out, and then all of its bodily fluids flow into the foot, and then it pulls the empty part of itself behind. This thing here is called a pseudopod. Pod is Greek for foot. Pseudo means false or fake. So there's your biology lesson for the day. But pseudo means false. Something that looks like it might be, but it's not. So a pseudo square is something that's not a square, but it sort of looks like it is. And I don't mean like the geometry square. I mean like in algebra, something squared. Let me give you an example. We've actually run into this before. X to the 10th plus 7x to the 5th plus, let me see, 10. And I'm going to ask you to factor it. There's something that should catch your eye immediately about this thing. It does have 3 terms. So you might be thinking, hey, unfoil might work. Well, there's a problem. What's an immediate problem with unfoil? Everybody remember 3, 2, 1? Go. Yeah, it has to be a degree of 2. This thing has a degree of 10, which is huge. In other words, unfoil would basically say I give up. But ironically enough, it does factor. We're going to use substitute. I just remembered why this lesson can be a little annoying for me. Everybody else thinks it's hysterical. I'll tell you why in a minute. But I don't know why. But historically speaking, substitution means you replace it with something. Substitution, let me just tell you what I mean, and then I'll actually show you, and then I'll tell you what the joke is. It says use a variable, pretty much any variable you want, in place of this is not a technical math term, but the icky part. Whatever's making this thing more complicated, replace it with a single variable. And by the way, this is sometimes called the pseudo-square. The pseudo-square is the replacement of the icky part. So what is the pseudo-square? The thing that you actually replace. So the substitute, you substitute the variable for, and please write this down, it'll speed up your homework. The second to last term without the coefficient, without its coefficient. So the thing we're going to replace, look for the second to last term, drop the coefficient, and see what's left. Somebody tell me what that would be in this case. Look for the second to last term and throw away the coefficient. Yeah. X to the 5th. Here's what I'm going to do. Oh, and here's where it finally gets weird. For whatever reason, hundreds of years ago, I do not know why, and it's actually kind of annoying, but the letter that mathematicians loved to use in problems like this was the letter U. Now, Now, it gets into it's very awkward in English. So here's what I'm going to do. U equals, and I'm going to do this substitution trick. So U equals x to the 5th. I haven't gotten to the annoying funny part yet. You'll probably know when we get there. Can somebody rewrite this whole thing using the letter U instead of the letter x? And don't just do U to the 10th plus 7U. Every time you see an x to the 5th, replace it with U. I'll do this first one for you. I'm gonna do it backwards. This is a plain old 10. Can you tell me what this term would be? What would it look like now if I did a substitution? Yeah.
Wait, what?
Leave the 7.
Alright.
Well, what do you replace x to the 5th with?
7U.
Yeah. That's 7U. Ever see? X to the 5th got replaced with the letter U. Now this is a little tricky because I don't see x to the 5th. Anybody take a wild guess what it is?
10U.
Good guess. That'd be if the 10 is in front. Isabel. That's U squared, believe it or not. If you don't believe me, x to the 5th squared is what? What do you do with power on power? Let's see. What's the rule for power on power? Like this. Yeah. If they're if on the same level you add them, multiply them. That's x to the 10th, which is exactly what we want. Look at this brand new problem you have now. Can you factor that? Give me an idea of how. Go. What method? You were right. On FOIL.
My goodness, Mia.
3 terms. Degree of 2. 1 in front. Can you find 2 numbers that add up to 7 and multiply to 10? Ding, 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 ding. Now, what would I put here and here? Yeah. U and U. This is where it starts getting annoying. You can probably figure out why. U plus 5, U plus 2. Now, we're not quite done. You remember the original problem had x's in it? The next rule is the rule that everybody learned in kindergarten. When you're done playing with something, put it back where you found it. every year or something. So what's the rule you all learned in kindergarten? Take a nap at 12. Don't tempt. But this is the totally annoying part. You have to figure out what U is. So what is U? See, I used to teach in an inner city school, and this just completely floored everybody in the room. I mean, well, first of all, I grew up on a farm in the middle of Wisconsin. I was teaching in an inner city school in Chicago. And so people are coming up and saying, "Yo, man, Mr. Cochran, don't even trip on me, straight up." I'm a snap on this guy. Come on, wait, what? Can you have a translator here? What the heck? So, and they would say like, so now it sounds like I'm from the hood. I said, "Yo, man, what is you? What is you, homie?" So anyway, you'll never hear this same way again. But what is U? What is the letter U? What's it stand? Mathematically, what does the letter U stand for? Somebody help me out with this problem. So let me see. Andy, help me out. What does U represent? Yeah, man, U is x to the 5th. That's right. So you replace it with x to the 5th plus 5, x to the 5th plus 2, and that's your final answer. Does that make sense? I replaced the big, complicated part with something that looked nice and small, and then the factoring was easy. Then I just put it back where I found it, and we're done. You would be a lot less awkward if they had used the letter V or something. But yeah. I'm not making this up just for a joke. Like 80% of the books in the world use the letter U, especially when you get into calculus. So yeah, when you get into calculus, you're going to get this silly, you're going to get the smack talk lesson. Does that kind of make sense so far? I can erase my amoeba. Let me give you another example. Now, I'm going to do something that looks extremely, extremely strange. How strange should I make it? Okay.
Oh, okay.
Yeah. I would like to factor this thing. Try to write it down. This is lowercase l, by the way. This is ln. If you have a scientific calculator at home, you might see this as one of the buttons. What is it? I'm not going to tell you. Because you don't need to know. Actually, I'll tell you. It's called the natural logarithm. I'm very sorry to ask. Well, you didn't ask. I just told you. But the ln of x is a complicated problem that you probably won't run into until pre-calc. Maybe at the end of Algebra 2, if we go fast. But logarithms are they're not that hard to do, but they're definitely beyond first year algebra. I brought this in just because it looks weird. It's a weird Algebra 2 / pre-calc function that has nothing to do with our class. I just brought it in because it looks like a monster. And it kind of does. I want you to factor. Yeah?
You could switch, you could do it by grouping.
You could factor by grouping, by the way. You notice there are 4 terms? I would like to do something else first. By the way, you could do that, and you would actually get the right answer. Remember I said this substitution thing is optional? There are some people who would just look at this and say, I can unfoil this. X to the 5th, X to the 5th, 5 and 2. Bam. And go faster. Remember, substitution is optional. Not for this worksheet, I do want you to do it. But on any test and in the world, it's optional. It's designed to make things look better and easier. But if you can do it straight away, there's no law against it. Okay? So you could theoretically do this with factor by grouping. But I want to do a substitution. U equals what? U is what? Your dog is what? There you go.
Is it the LNX thing?
Yeah, that's the ln of x thing. ln parentheses x. Because it's the second to last term, drop the coefficient. Can somebody rewrite this whole mess with that new substitution? Eric, help me out. What is this thing?
Should be 3u squared.
3u cubed plus
5u squared.
Yep.
And 15u.
Yep. And then just 25 because there's no substitution there. Looks a lot smoother. Now you can factor by grouping. I'm going to kind of turbo this because I got one more example I want to show you. This pulls out a u squared with a 3u plus 5 behind. This pulls out a 5 with a 3u plus 5 behind. And that's good news. The parentheses match. Pull it out in front. So 3u plus 5. And then the leftovers are u squared plus 5. Normally that'd be my final answer. But when you're done playing with u, that's actually one of the more awkward versions I've ever said. When you're done playing with the letter, you put it back where you found it. I'm going to stop that in my own conversation right now. It's going to be 3 ln of x plus 5. And this is going to be ln of x squared plus 5. And that's your final answer. It looks horrendous, I'll be the first to admit that. but that's the right answer. Okay. Last one, and the worksheet is going to do this to you. I want to get you prepared for this. Is the following. First of all, quick review from last year. 2x over 5 is equal to 2 over 5x. True or false? It's right or wrong? Is it true or false? We break. Go.
Not false.
How would you prove it?
2x divided by 5.
Well, give me a hint. This is multiplying.
Oh, no, never mind, it is.
It is true. How do you prove that? How do you multiply a whole number times a fraction? Is it? Try. How do you multiply a whole number times a fraction? Just a guess.
You do, well, for one.
Yeah, put a 1 on it.
It'd be like 1x over 1x. Something like
Yeah.
that.
So go ahead and multiply. What's 2 times x?
2x.
2x, and then 5 times 1? They're the same. It is true. So in other words, you can put an x on top, or you can put it off to the side, just not on the bottom. That would change the answer. Question? Yeah.
Okay, so it's true.
Here, yeah, like 5 minutes left. So keep that in mind. We do this. I'd like to get back to this. Now this got royally strange, royally fast. X squared over y squared. First of all, it's not a polynomial. Doesn't have the same base. And, well, it sort of does. But anything with variables in the basement, not a polynomial. I want to try it anyway. But I want everybody to agree, this looks like a disaster. Can anybody tell me what you could substitute? How do you find? I don't want to say it. How do you find u? Here I am. Now, how do you find what the how do you say this? How do you find what the letter u should represent? Go. Second last term without the coefficient. What would that be in this case? It's x over y. If you remember, this is the same as 9 times x over 1. 9 is the coefficient. So I'm going to do x over y. Could you rewrite this for me? Go backwards. This is just 8. Plus what? You can use this version. 9u. Any guesses as to what this is? That's u squared, believe it or not. Because if you have x over y squared, it does work. It's x squared over y squared. Can anybody factor this? Brendan.
Yeah.
What method? On FOIL. Do it.
Well, you have u plus 8,
Yep.
and then u plus 9. No,
Uh,
yeah, u plus 1.
1. Nice. They add up to 9, multiplied by 8. Now you're almost done. There's one last thing. Not doing the games. Come on, what is u? What is u? What is the letter u? What does it represent? Go. Yes, x over y. Put it back where you found it. X over y plus 8. X over y plus 1. Does that make sense? Any questions? Nice. Okay. So, since ended. I'm not going to flip it again. It was on film. So, bit of news that I'm sure will crush everybody. I cannot give homework tonight because I have a little bit more notes. Yeah, I'm sure everybody will be crying in their beverage tonight around 8 p.m. You'll be going through withdrawal on this, trust me. But I will give you the worksheet tomorrow. If anybody wants it today, I can give it to you. Why not? You do not have to do this today, but you can start if you like. There are some review problems. The review problems you should be able to do. So if you want to get those out of the way ahead of time, you have less to do tomorrow. Absolutely okay. We're going to pray in about 30 seconds.
Mr. Crawford, should I stop the video?
Not quite yet. I'll get the last final prayer. But thank you. So for those of you listening at home, this is in class 66. You will be due not tomorrow, but Friday. Do keep in mind, the following week, next week, is probably the chapter test. It's probably going to be on Friday. Okay? Maybe Thursday, we'll see. All right, at this point, let us pray. Face the crucifix, y'all. Yo, now I'm doing it. So. Yo, where's the crucifix, Joe? Straight up. Let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, the world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Amen. All right. See y'all later. Somebody hit the record button.